Thanks. Thanks, everyone. Hope everyone can hear me clearly. Right. Great. So, yeah, uh, glad to be able to present this session to all of you. And I think, like, preparing for this request, there was some things that I needed to refresh myself on also. But what we will basically be aiming at is looking at a practical approach, a more practical approach of how we could use some of the concepts which we might not technically always go to when we are developing React applications or uh, trying to optimize performance. So, yeah, with that, let's kick off. Let me start screens here. Right. So basically, this is the agenda for today. So we'll be looking at a small introduction into why performance is needed, like performance in a whole, as a whole, and also how we can focus, especially when it comes to web applications, how we need to focus on performance and why it's absolutely necessary, especially in modern times. And also we'll be looking at, we'll be dividing the topic into two sections. So one is maximizing the performance of our React code, and we'll be touching on things like profiling, where we will go through a small sample application, profile some of the code that we have and see how we can optimize that. And also, after that, we'll be looking at maximizing the overall performance of your web applications, which I believe is very important nowadays as well. So we'll be looking at the core web vitals, and also we'll be looking at some analysis where we go and analyze some of the actual production build code that we have to see if everything is optimum or if we could do something different where we could gain some performance enhancements. And yeah, finally, we will take a round of questions. And if you have any questions during the session, please feel free to ask it at the end, and will try my best to answer it. If not, you can drop it on the chat, and we can get back to you at any point if we run out of time in giving you the answers. So yeah, let's start off. And basically, like I mentioned in the slide, modern web development, if you look at performance, it basically refers to speed and efficiency of a website or web application. And there are a few factors. I'm sure all of you as users of web applications and websites would agree with some of these factors that we perceive as good performance of a website, so or a web application. So basically, it's page load time. So if there is faster page load time, it gives you better user experience, and it gives you some sense of satisfaction. So that is, I think, a critical factor in gauging performance. And also responsiveness. Responsiveness in the sense how responsive the UI is without any lags, like smooth animations, smooth transitions, flows within the application as you navigate and interact with an application. And also, if you go in a bit more depth, we could also consider resource usage like CPU, memory usages, how that affects performance of applications and whatnot. So that is a critical factor as well when we look at the general performance consideration. And also scalability, like how much you could scale your application, what is the breaking point, how when you scale up to certain levels, how would all the other factors mentioned above, how would they complement each other, how would they work together? So these are, I think, some of the things when we think of performance as a whole, some things that we could think of, and I think you all would agree with me that as users ourselves, these are some of the things that could cause pain points for us as well. If we go to a particular site or use some application, if something is lacking, especially in page load times responsiveness, we would feel it, and maybe we would file an alternative, or move into another site that offers the same functionality or benefit. So yeah, that is something like a small introduction into performance. And why it really matters is that in modern day applications, and with the current competitiveness, uh, there are a lot of things that uh, perform like bad performance can hit you in a bad way, like especially if you're a company that sells a service like a web application or something like that. Bad performance will reduce your conversion rates. uh, Poor performance could destroy a brand perception that is already built among users. And also, like on the other side of it, like if there is faster website performance, you can gain a competitive advantage over your competitors. And also it could improve your brand awareness. So I just noted down some stats, I think, which were very interesting as I was preparing for this. And what I found out was, like, especially if you look at this whole topic of performance and like compare it with use like look at the stats from something like an e-commerce site. uh, the stats that I found was that for e-commerce sites, a 7% drop in conversion means lost sales. And for a site that generates roughly $10,000 a day, a drop by 7% means a loss of over $2.5 million a year. That's just because maybe your uh, page load time was 1 second slow. Like generally, we know that general perceived performance, like it's at a like a standard of like 3 seconds. So let's say, or 2 seconds, and if you just went 1 second above that industry standard, it could mean a loss in so many factors. And also, like especially in e-commerce websites, I think they do a lot of ad campaigns, advertising, and all of these would negatively impact ad revenue and things like that. Page hits would drop down, things like that. And business wise, it would be a big loss if we have not correctly tuned in our application for performance. So what we'll be looking at mainly is how we could, like I mentioned earlier, how we could improve performance, especially with React, because that is one of the major libraries that are in use out there today, one of the leading libraries. And uh, there are applications in a wide range of domains and products that use React. So let's dive into how we could maximize our performance of our React code. And just to start things up, I won't go into detail because I believe that you could get most of the information off the internet. But let me just touch on some things that I feel are critical and vital, so that like we go about our session today in a step-by-step approach. So feel free, relax, and let's dive into React optimization. So yeah, as you see, I think on the right of your screen, you can see a DOM tree, right? So that's technically how React would represent the actual browser DOM that we see. So React has this concept called virtual DOM, which I believe most of you are familiar with, and you could get more information from the web. So React actually, how it internally handles performance and is built in that kind of way is it creates a virtual DOM that is held in memory. So it's an actual representation of the actual browser DOM. So there is a copy of it in memory, which is called the virtual DOM. And how React updates. So like once we do some interaction, React will, there is a process called rendering in React. So that React breaks this down into two segments. So there is like a rendering phase and a commit phase. So in the rendering phase, technically what would happen is like whatever interactions or whatever updates that happen to any of the nodes or any of the interactive components that you are working with or elements on the page that would update some nodes on the virtual DOM, and then React would compare it with a previous version of the DOM, that virtual DOM that it has, find the best or the least path or the quickest path to update these virtual DOM nodes into the actual DOM, because actual DOM node updates are very costly in terms of CPU, memory, and things like that, and and the use of the JavaScript engine. So basically, what React does is it creates a sort of a diff between, okay, whatever you need to commit brand new, whatever was there, it creates a difference between the two, identifies what needs to be updated, and then in the commit phase, it pushes those updates into the actual DOM. So basically, like you see on screen, if you look at the GIF, animated GIF that is going on here, so you would see the yellow nodes are nodes that need to be updated here. And then you can see, like as it moves on, there is like it turns into a brownish color node, and then you see parent nodes itself are being rendered. So the way how React works is, so there is this whole subtree parent child relationship that works with React, and if there is an update technically to one of the parent components, technically it would update the entire subtree, right? So there are mechanisms where React internally uses where we could optimize this workflow. So we'll be looking at some things like that. And also, if you don't structure your components correctly, this would mean that an entire, like you might not actually need some nodes to be updated, but because of the way that you've written your components or the way you've composed your components, it could mean that one slight mistake could be updating, like you would have wasted rendering cycles that once put together, like into large applications, once these grow, these performance issues grow up, it could accumulate and lead into like slow, responsive, laggy user interfaces. So let's look at how we can improve some of these aspects in our code. Right. And these are some of the things that I would like to touch base on with you today. So most of it, I think, will be walking through some code and looking at how we can practically do some changes based on some of these optimization techniques that I mentioned here. So when we are working with React components, there is this, for further reference, I think you could always get more details off the web. So there is a concept called moving state down, lift content up, and create isolated components, like I mentioned earlier, so that the parent-child relationship that React has and how it updates the subtrees and stuff like that, we could minimize which subtree gets updated and we could also minimize unwanted re-renders. And also there is memoizing of components. We could use something like React Memo, sorry, which we could use to stop unwanted re-renders. And also there are some hooks. I think I'm running through this because I'm pretty sure that most of you are familiar with this, but let's look at practically how we could make use of these functionalities that we have. So use memo, use callbacks, hooks are something that we can use to uh, optimize a certain level of performance. React fragments, I think it's something that we can use to reduce unnecessary DOM node creation, where we sometimes tend to wrap everything like in a div tag, but technically we need not do that. If it's possible, it's better to use React fragments, which technically groups multiple nodes. And also like there are things like throttling, debouncing. React 18 has concurrency, automatic batching transitions and things like that. So I think it's good if we look at some code examples, and then I can walk through how we could actually optimize some of these code issues that we see. So let me move into, I've done a small sample application here. So let me move into that, and let's see how we could address some issues that are visible clearly in this particular application. So yeah, to get started, this is just a sample application, and I've set this up with Vite running React 18, and let me open up my dev tools here. Right, and I hope the screen is visible. And technically, what we will do is I'll be mainly using the profiler, which comes off React DevTools. That's an add-on that you can add into your browser. So if you have not, if you and if you are not aware of it, just add it. It's quite useful, and let's go through how we can use this in a practical way. So technically, what I'll do now is I'll reload and start profiling. Let's do a couple of actions and look at how our React code performs and what we can do to optimize our React components. So let me start the profiler here. Yeah. So let me like filter out something here, add in a price, add in a rating, and apply a filter. And yeah, now I'm seeing this filter being applied here. So notice that there are various components. There is a search filter section, there is a footer, and the search is contained in a header. There is a product list component here. So let's go back, stop our profiling. Right. And technically what this would do is yeah. So what you would see up here is what we would call the commit information. So these are commits that would happen once we react or like interact with our application, right? So these are, let's focus on these larger two commits like towards the end and see uh, what information we can gain out of this. So like you see, these mentions the times that it took to like commit these various changes, and also it gives you the reason, right? If you just hover over these various sections, it gives you the reason as to why this particular component rendered, right? And if I look at the app component here, it says hook 4 changed. And what is hook 4? if we come into our components, hook4 is my filters component state, which I've updated here when I clicked on the apply filters, right? And so one by one, I think we can go through that. And there is, I've created a dummy, like a non functional component. It's called expensive tree. And what I've done there is, if I show you the code for expensive tree, I basically added in a delay so that like we are you just need to I'll be when I'm going through this application, I'll be just giving you insights as to how you could translate this into your code base. So you could be having like situations where there are uh, uh, lags or like various other processing that happens which mimic something like an expensive process, right? So that's what we see here, and this is the code in expensively, and that's why you see this uh, flame graph mentioning that, okay, the parent component, which is the search component in this sense, rendered, and then that caused the expensive tree to render and commit here, which took 200 milliseconds. And that's in React terms, that's quite a lot of time that it takes to update the DOM. So that's why it's mentioned here as an expensive or like the if you look at the color legend, if you see anything in yellow, that means it took like time wise, it's time consuming and it's something that we could optimize. So uh, like I mentioned in the slide, there are some techniques that we can use, and let's see based on those techniques how we could optimize something like this, where we could probably get rid of this. So let's dive into the code, and if you look at the code, I hope that the code is visible to you, visible enough. And if you look at this, so you will see this search component, right? And in this search component, I have something called an expensive tree, which we saw in our graph there. And if you recall the actions that I did, basically what I did was go and update some filters, right? So if you see this filter bar will contain the various filters that I had, and on button click, I would update some state on the app component, which has all my products, and that update is now causing all the components on this page to re-render, right? So technically, like if we look at it, there is no need for header to re-render or search to re-render, right? Because I was doing I was doing a change related to filters, and technically filters should apply to the products, right? The product listing that we had on the screen, right? If I did something on my filters here, that would apply a change on my products here. Technically, my search, my header, my footer need not render, right? So you could translate this into your application and think of it like that. It might not be the same thing. It might be like completely different, but look at the approach and the thinking behind how we start off with performance optimizations here. So, like I mentioned, we could skip updating our search because there was nothing needed for search component to get updated or header to get updated. But in the way we have written our code, since our app component has like the product filtered products, when we click on apply filters, it would run some filtering logic and set my filtered products. So that in turn, since my state got updated here in my app component, that would technically update everything. So let's look at one approach that is generally used. So I mentioned something on the lines of React memo, and I think most of y'all in a case like this, I think even I would go and try to wrap these components in React memo because it does like a comparison on the props coming into the component. If there is no change, uh, if there is no change during that comparison, it basically stops uh, that component from re-rendering. But before that, generally, some techniques that we could use that I mentioned earlier, like in the slide, is this concept in this concept called lift content up, right? So basically, what we are trying to do here is, if we look at our expensive tree that was causing the major issue there, there's this concept where if we pass in components through the child prop, right, using the child prop concept, uh, that although there is some rendering that happens, since in our case the child prop doesn't update, like the child prop in itself doesn't change when we pass it. Rather than having a search component render directly here, we could use, like we could lift this expensive tree up one level and pass it as a child and render it as a child prop here, and try to get rid of some of these issues. So think about the code and how you try to optimize performance, and see if this is one of the techniques that you could use to optimize your code. So let's try that out. So instead, let me comment this out here. And comment that out as well. For children here, right? And basically what I'm doing now here is lifting this component up, right? So basically we are providing expensive tree as a child component into search, and let's see if that does some change in our profile. Right, so let's just refresh this because sometimes profiler, it's a known case that profiler doesn't work sometimes, like once you refresh, and let's start profiling again. Right, let's do the same thing, genes, search 400, rating 4, apply the filter, stop the profile. All right, and still here you would see something like, okay, the first render is anyway not a problem. So like all of these, like if you notice, there has to be a first render in some case anyway, right? So the first render, like if you notice all of these commit messages, it gives you the reason as, okay, this is the first time the component render. And then you go to the next commit, it tells you that, okay, hook 2 changed, right? So hook 2 in a case is, if you look at uh, the component setup here, is our products. So since we fetch products, components get updated, and this tells us that, okay, component search component rendered, right? Sorry, it's, yeah, expensive tree tells us that the parent component rendered. So that's why I'm updating my search, right? So technically, if you look at it, the props that have changed that are mentioned here is on search and children, right? So if we look at on search. Like, so still we have the issue of the expensive tree being rendered in some way, right? And based on what we saw in the reason, it also mentions that, okay, our handle search is changing, right? And if you look at the code that we wired up here, I'm passing like a callback so that if I update my search in any way, it would go and uh, update the search term state that I have in my application, in my app component here, right? So if you look at this function here, technically what happens is every time a React component re-renders, there is a new reference created with this function. So that's why with the new reference passed into onSearch, even if we wrap this in, even if we wrap this search in something like a memo, you would see that an update happened. So let's just try that out as well. So I can try to update this update performance by wrapping this in a memo. And let's look at if this does some change for us in terms of performance. Right, so we start profiling again. Live filters and stop. Right, so first render is okay. And now we see, okay, memo, we have wrapped our search with memo, React memo, but still we notice that the on search, it mentions that the on search has changed and so has the children, right? So here technically something that we should know is, like I mentioned earlier, when we have just a function reference as a callback, whenever React runs a re-render cycle, there would be a new reference here, meaning that, okay, React would identify that, okay, there is a new reference in my callback here, and I need to update search component. So something that React gives us to optimize this is the use of the hook use callback, which we could use to wrap this function here. So I have it already done here. So basically when you wrap something with use callback, what it would do is you can mention dependencies here. Since I don't have a dependency, I'll mark it as empty dependency. And what would happen technically is this would only create a new reference if there is an update in any of the dependencies. Until then, it would pass back the same handle search function. Okay, now let's have a look at if this change uh, gave us an optimization. Let's get this back. Go through the same process. Right, and stop. Okay. Here now you would see that the props that changed have differed, right? So no longer are we getting on search prop change event, right? I think if you noticed it before and now, uh, within brackets here, you would have seen props changed. Earlier we had on search. So just wrapping it in that callback gave us some sort of a change. And although we are still seeing this expensive tree being rendered here, because the app component is rendered, uh, there is some change that has happened into a search component, right? So that is some change, that is some optimization technique that we could use. And like when we continue to like type in, okay, so I think I didn't show that before. So let me quickly show that to you. So when we had our expensive tree in our search there, there was a perceived. So, like if you say I'm typing it quite fast, but you notice, I think you can clearly see that there is a lag in updating the search here. That is because the expensive tree is taking up resources and cycles, and it's blocking the rendering of my component and search text back here. Right, so that's why we did the initial refactor and lifting up. Right, so let's keep memo here and let's keep our expensive tree in a lifted up state so that we can continue in optimizing our code. Right, so that is like one technique where we could like lift up and also now I think if you see the difference, sorry. As you see, it's very responsive now. Although my search component is re-rendering, since I've like lifted up this expensive tree up and passed it as a child of search, it's not blocking my render process, right? So that's one technique and concept that we can use to optimize. And another thing, I think we looked at uh, let's look at our graph again, and we see, okay, if we look at our commit cycles, we see header is being re-rendered because props changed, and then we see, yeah, right throughout, we see the same expensive tree being re-rendered because of like the blocking code that we have in there. So let's comment this out for now and continue with some more techniques that we can check out. So let's try to run the profile up again. Right, so let me do the same thing. Now I commented out my expensive tree logic there. We've run genes 400 and stop this. Right, so okay. Now if you look at it, right, apart from the expensive like component, we see like filter bar changing due to the on filter changes, products changing because of like my product list getting updated, things like that. And you would see that like footer is not rendered. So if you look at the footer component here, yeah. So since there isn't like a process involved there, it's not getting rendered. And so something that we can use to further optimize, for example, our product list here. So you would see like as we update our filters and as the products get updated, you would see that there are some uh, renders that happen here, and then you would see, okay, at another point in your commit, yeah. So when hook changed, which is our filter logic changed here, we see that our product items are re-rendered because our product list is. So we can do like an optimize if like, for example, if product item is like an expensive update, you could do something like wrap a product item in a memo, and then that would give us some perceived performance benefit there. So one thing that we need to be clear is don't try to wrap just because it's an option. Don't try to wrap everything in like a React memo or a callback or something like that. It's you know your code, you know what sort of complex logic can be involved with the code, and it's up to your discretion to identify, okay, when do I need to use memo, when do I need to use callback, so that, okay, if my callback is causing me a problem for my component to re-render, how can I wrap it in a use callback and stop my subtree from re-rendering? Or how can I use memo if my uh, some component has like a complex logic or complex functionality and multiple subtrees? How do I stop, maybe use a memo and stop it re-rendering there? So those are some of the decisions that you need to make on the go, on the run, so that we could get the best out of whatever we have and not like overuse it, right? So I think we are running out of a bit of time as well. So let me try to uh, go through some of the other stuff that we have. Let's try just one more. Here, let's do the same thing. And we have apply, come back to the profiler, stop the profiler. And now you would see like in your commit cycle. So earlier, if you noticed, like when product list changed, obviously the product item changed for the first time. But then onwards, now you would see that since we've added React memo, like wrapped our product item, which is this technically this card uh, here. It's now memoizing that and not re-rendering unless absolutely needed, right? So those are some of the optimization considerations that you all could do. And something to add on, uh, we go back to our slide. Yeah. React 18. So since I'm using React 18, with React 18, there is this whole concept around concurrency. And like I have a link here, but I don't want to go and look into details. But basically, what happens is with React 18, it allows this whole render commit cycle to be deferred, in the sense you can mark some render cycle as urgent, mark something as non-urgent, and which was not possible earlier. And then similar to like what we saw on the expensive tree, and how that how just typing on the search blocked that entire process. Similar to something that we would use like with debouncing or something like that, if you all are familiar with, where it would not update on every keystroke. So there is a mechanism using transitions to mark certain updates as urgent and certain updates as non-urgent. And how React would handle it is it would check the main, go back to the main thread, and every like 5 milliseconds, it would check if there are any urgent tasks. It would execute those and hold on to the non-urgent tasks. And then whenever React gets some free browser utilization time, it would commit those and render those on the DOM. So that's how concurrency works. So that's an inbuilt way of how React optimizes performance as well. So apart from this, uh, if you're working with like lists, images, something that you can use to optimize is like list virtualization or lazy loading images. So here I have not gone into that level of detail because it's like a limited time that we have. And if you're like using Redux, something similar to like we use with React Memo, Redux has libraries like reselect, which gives you some sort of memoization. Right, and I hope, like, if you have any questions in this regard, you can ask it towards the end, and let's quickly move into our next section. So initially we touched on React performance, and now let's look at how some things like how we could do some changes to that affect our overall application performance. Right. So some of the main things, one of the main things that I think you all might be aware of is the core web vitals. These are the stuff that you see on screen: largest content rule paint, first input delay, cumulative layout shift are three of the main metrics that are evaluated in determining like Lighthouse scores, page insight scores, and how like Google ranks your application. So let's go back to our application, run some Lighthouse tests, run some bundle analysis, and see how we could, some techniques that we could use to optimize our overall performance. So coming back to my application, let me refresh, get it back to our normal state. And in Chrome, you would have the Lighthouse tab in your DevTools. So what you need to do is click the Analyze Payload button, Page Load button, and let it run a small analysis for you. Right, and you would get some scores like similar to this, right? And some of the metrics that we mentioned are like scored here. And like you see, if it's green, technically it's good. You get higher scores if the metrics red a green value. That means you have scored well, and the more higher you get in these various metrics, the lower performance score that you would get. So let's look at some of these and see how we could, some changes that we could use to update our performance. So something that you would say, I think, is let's start off with CLS. So cumulative layout shift, or CLS, is something that uh, is measured based on like when your web page loads, how much of a visual change the user sees in the layout. So if I go back to my page and if I reload it, if you just look at this whole product list section, you'll notice that until it loads, like I see the actual footer, and then when my products load, it pushes the footer down, and there is like a change in this layout. So if we go and check our, uh, if you go and click on this view original trace, right, it would load up and you would see something, a section called layout shifts. And like if you zoom in, it would like mention some areas where the actual layout shift happened. And like it would, in some cases, it would highlight. And I think in the background, you can see when I hover over this in the background, my browser window is getting highlighted, and like it's showing in like a blue like an overlay there. I think you all can see it, right? Right. So that means that there is something like wrong, and something to do with my like entire component is affecting this CLS. And if you go back to our Lighthouse, and if we look at some of the suggestions, and we look at CLS, yeah, it tells us avoid large layout shifts, and it shows us the footer here, which is contributing to a higher score because that was the biggest layout shift that you saw. and then there is a layout shift, which is of course coded as 0, but mainly our CLS contribution here mainly is the footer. So let's look at something on how we could change this behavior. So I think you all would have seen loading skeletons. That's something, especially with Next.js and all modern applications, they try to, rather than just showing a small spinner or a loader, they try to uh, show like a loading skeleton, which technically is the best in this case, since that would cause the cause a minimal layout shift, since we have everything in place saying, okay, un until my page or products load, like I'm not going to change anything for the user. The user experience before and after my products have loaded are technically going to be the same. So let's look at something. I've done some coding here so that I can have some skeleton behavior. So let's try to add this in, and let's see. So technically what I'm doing is, what I'm doing in my code is, until I have any products, I'm showing a product item, but with a skeleton mode, right? And let's see how the change that we do affects or changes our CLS code, right? So now you would see, I think it was visible, like until my products were loaded, uh, the screen was pretty much the same, right? And there is no shift. If you look at the scroll bar here, there is hardly any change in the scroll bar, right? And technically that would give us a better Lighthouse score. So let's just go and run another analysis and check what Lighthouse has to tell us. Right. So there is a slight decrease. Okay, let's try. Okay. So now it's pointing us in the direction of various images, but we don't see the main footer CLS change that was being applied early, right? So like these, like evaluating each and every change that you do, doing retests, optimizing, these are some of the ways that you can go ahead and like small tweaks and changes that you could do to optimize your score here. And then like looking at some of the other content. So we see largest contentful paint here, so LCP, and it tells us, okay, reduce unused JavaScript, minify JavaScript, things like that. So I'm running my development version here, so that's why you're seeing minify JavaScript suggestion here. And also, if you look at this, it gives us like suggestions saying, okay, try to optimize this. Maybe you can optimize the image. In this case, I'm running raw images, not optimized. So you can run it through image optimizers, things like that, and get an optimized score. So let's quickly do something like this. Let me try to comment this out and run a yarn preview. Okay. Not sure why this is not. Okay, that's fine. yarn build. Sorry. Give it a second. Yeah, I forgot to do a yarn build. So let's do a yarn build there and do a yarn that I'm having my production version. Yeah. So now let's quickly do a survey here. Right. And now you see like some of the changes that we just minifying the code itself gave us optimization. So technically, that's the best way to go, like run your profile against minified code. And also something else that you all could do is like, especially font loading and stuff are generally considered like blocking actions. So here, something that you could do is like do a pre-connect onto your fonts, things like that. That could also reduce your perceived score. So let's quickly do a yarn build. Running out of time, but let me speed up a bit. Right, and a yarn build. Right, and yarn. Okay, now you'll notice that like this could differ when you're running off local, unless like until you have this hosted on a server and stuff. But whatever slight changes that we do affects a lot in our overall performance, right? And like one thing, so this is a bit on how we could optimize various things in our code to get better performance on like Lighthouse scores, page insights, which would also like help you get better Google rankings once you like host your site. This is something that is important as well. And one more thing that I would like to show you all, or a couple of more things that I would like to show you all, is something like this. So I've configured like a tool here, which I would like to show. So for this demonstration purpose, I've used Lodash just to show something. There's this concept called tree shaking. Let me touch on that really quick. So what tree shaking does is basically when you bundle your code and get it ready for production, it just discards everything that you have not used and only uses code that you really need, right? So something like when you're using something like a library like Lodash, if you do an import like this, like a general import, what you would notice is, right? Let me run a yarn build here, and I've like configured a bundle analyzer. And what that would do is it will like analyze my final build output and give me uh, a breakdown. And if you see here, this is the analysis that I got running the build. And according to this, Lodash is my largest contributor to my bundle sizes, right? But if you look at my code, what I've just only used is just the filter, right? I've not used anything else. So just for the purpose of using this single function, like having Lodash the entire library bundle. So one thing in this case you all could do is with Lodash thing with a library like Lodash, something that you all could do is directly use filter like this and then update underscore filter to just use filter. So now if we run the yarn build, these are, I think, little things that we tend to overlook, but once you try to analyze your bundles, you would notice that it makes a significant difference. And now if you see, uh, comparing our previous time. Earlier, I was loading 547 kilobytes. Now with that small change, I dropped it down to 84 kilobytes, right? So I'm like saving 400 and something odd kilobytes, which is a lot, right? So minor adjustments like that matter at the end of the day. And also another thing I think which you all are probably familiar with is lazy loading. So I would encourage you, especially if you are working with routers, if you have some conditional logic, try using lazy loading, because without lazy loading, if you try to directly import components, if even if you even if your component is rendered based on a condition, technically what happens is, because of this code import, it is bundled up into your initial code bundles that need to be shipped out into your browser. But with something like lazy loading, that would speed up the process a bit and defer the loading of the pagination in this case. So what I've done here in this example is deferred the pagination, because uh, up until my product list loads, I technically don't need this, and it's like a below the fold uh, component that technically is not visible at once. So I can use a method like lazy loading to optimize my bundles a bit more. So let's yarn build again and check uh, if there is a difference there, right? Yeah, and it gave me this update. So if we look at 9248, 247, so you might notice that there is a slight increase in actual size of the chunk, right? But something additional is now I'm having my pagination separate, right? And it's loaded as a separate chunk. So that gives me some benefit as well, where whenever chunks are loaded in different ways in React, uh, initial load time, initial perceived performance, and things like that, you could benefit out of, right? So let's quickly run one final yarn preview and check for lighthouse analysis, and let's see what it comes up. Okay, so like I mentioned, this technically doesn't mean that whatever changes that we did gave us a lower score. It's just that there are, especially when you're working locally, when you're with network connections and stuff like that, loading images, all of this could contribute. So this minor change doesn't actually reflect 100% the changes that we have done. But if you look at it as a whole and look at how much of usable code that you're shipping onto your browser, the footprint that we have, things like that, those things finally in your end product will definitely help you to optimize your React performance. And also, a benefit with React is, once you have your bundle, since it's a static distribution, you can host it on a CDN, right? And uh, that would give you an added benefit of edge caching and stuff like that, which would serve out your application faster in various regions and in various ways that you configure it. So these are some of the overall performance considerations I think that we could think of. And I hope that some of the profiling that we did with React performance, some of the things that we looked at, like minor details that we looked at with Lighthouse bundle analyzer. So with Wheat, what I've done is Wheat has a bundle analyzer that you can use, and if you're using Webpack, there is a Webpack bundle analyzer. So you just need to configure it in a like add it in your package JSON and run like an analysis, and it would uh, evaluate your bundle. So these are some of the like what I mentioned today was some of the techniques that I use personally to like figure out, okay, when approaching my applications or the way I do things, okay, how can I improve my React performance versus how can I improve my overall web performance, and how like minor changes that I do could affect the final output and translate uh, to some of the changes, and also like benefit the web application, benefit clients. You might benefit uh, uh, basically it will also give you a sense of like accomplishment as well, like seeing like I think everyone would be happy. As a developer, I personally feel happy when I've like done some optimizations and see like good results out of it. So try these out. These are some of the methods that I believe that you all can use uh, to optimize your applications. So hope you received something out of what we went through today. I think we are slightly above the time. Sorry if I went a bit too in depth or too in detail in certain aspects, but really hope that you got something out of it. And yeah, that I think concludes what I wanted to present. And if we have any questions, now is the time for some questions, if you do have any.
Thank you, Stephen. I think he could do 6 more sessions. So if you would like another one, please do let us know. We do have one question. As a full stack developer, I wanted to know why you're interested in front end and why did you decide to specialize in it?
Yeah, so front end development to me, like I've not been a like a back end guy anyway, but what I see, like especially what I see is it's constantly evolving, and there are a lot of changes happening at the moment in the whole front end area, and there is so much to keep with, so many new things to get yourself involved in and like learn from it. So personally, uh, I like pursuing the front end space because of that, and like I like to make great like UIs, optimize them, get my brain tracking on them, and like yeah. So it's I like challenges also. So that's with like keeping up with all the frameworks, libraries. I think all of you would agree with me. There are so many changes that constantly come up, and yeah, keeping up to date and uh, learning from it and updating myself, yeah, drives me. So that's one reason.
Amazing. Does anyone else have any questions today before? I'm sorry, we did go a bit over time, but it's obviously a lot of scope in this topic to keep doing more sessions if we can convince Stephen. If there are no more questions, we might wrap it up. This session was recorded, so if there's anyone you know who had to leave early, or if you'd like to go, I mean, it was very in depth. So if there's something that you'd like to watch again, it'll be up next week. I will send you the link. Follow us on Instagram, LinkedIn, TikTok, and Facebook to get all the details. Thank you, everyone. Thank you, Stephen.
Yep, you're welcome. And if any of you have any questions or need further clarifications, or like this was just a just the small percent of what we could like fit into this time slot. So if you have any questions, please feel free to reach out. You can reach me on LinkedIn, or even you could reach out to Lulu, Priya, and you could get in touch, and we could see how could help you out.
All right.
Thanks for joining.
Have a great evening and see you next month.
Yep. Thanks everyone for joining, and hope you're able to get something out of this.